Okay, data scientists, we are now back for our week 5 lecture, 3 of 4. And now we are jumping into this week's 5 material. With that being said, let's go ahead and go over our overview of what we can expect for this ensuing week. So we want to make sure, guys, just like we did in week 4, let's keep our foot on the gas pedal and do a phenomenal week's work, making sure that you understand my deliverables as well as the module objectives for this current week 5. Okay. So, as we all are all data scientists, there are tasks with classification problems. Okay, which is a form of supervised learning in which we first train a model on data where the outcome is known and then apply the model to the data where the outcome is not known. So we know this as data scientists. This is what you're going to be seeing this week, guys. That's why I gave you that first over the top overview. Okay. Now, often we want to know the predicted probability that a case belongs to a class rather than having a module excuse me, simply assigned to binary classification. Most algorithms can return a probability score, which we call it propensity, of belonging to the class of interest. Okay, so classification is perhaps the most important form of prediction. It is the common it is common predictive modeling to train a number of different models, apply each to a holdout sample, and assess their performance. After a number of modules have been evaluated and tuned, and if there is enough data, a third holdout sample not used previously is used to estimate how the chosen model will perform with completely new data. Okay, so fundamentally, as data scientists, we should know the assessment process attempts to learn which model produces the most accurate and useful prediction always. Okay, so that right there, guys, for this week 5 is your overview. You're going to see that when I give you your deliverables for this week 5. So you want to make sure you take that in and really comprehend that, guys, because that's what I'm expecting out of you, to make sure you get a good lay of the land on. Make sure that you really comprehend, okay? Because that is my deliverable that I'm expecting out of you, that you're going to check all the boxes, that you truly understand those areas out of this week's content, learning material, as well as the chapters in the book, okay? So, with that being said, by the end of this module, which is this module 5 for week 5, I'm expecting 7 things that you have to have in your hip pocket, guys, to have a successful week. Okay. Number one, you have to be able to calculate the probabilities of Naiv's Bayes method. Okay. Number two, perform discriminant analysis. Then thirdly, describe logistics regression. Fourthly, you're going to have to be able to describe strategies for dealing with imbalanced data. If you guys are not familiar with that, a lot of times, in the public sector, when you're working with data, the data may not really be, I guess you can say, a way of being logical. That thus is the term imbalanced data. Our job as data scientists is to always cleanse the data to make it balanced as opposed to it being imbalanced. Okay, so that's something to be really mindful, okay, of this week. Okay, now fifth thing I'm looking for to make sure you guys have in your pocket by the end of the week is be able to explain how generalized linear models actually do work. Okay, and number 6 of 7, you're going to have to be able to use logistic regression models appropriately. And then last item, 7 of 7, for this lecture 3 or 4 that you're going to have to make sure that you have by the end of the week is be able to differentiate between generalized linear models and Poisson models. Okay, I'm gonna say that again. You're gonna have to be able to differentiate, right? That's the key. As I mentioned last week in week 4, being able to differentiate between generalized linear models and the Poisson models. Okay, so that differentiation, guys, is huge once again this week. Okay, alrighty. So that's going to be the premise of the 2 things that you're going to have to really make sure you know for this week 5. I gave you those several module objectives, and then I gave you, firstly, from the overview, my deliverables that I'm expecting out of you guys to knock out the box. So you're going to have to check those boxes off to make sure that you got those deliverables that I'm going to post on the announcement board along with the 7 uh, module objectives for this week 5. Okay, so our book material, okay, that you're going to appreciate coming out of our practical statistics for data science. Our book is all about, you're going to go into chapter 5, which is classification. Okay, you're going to appreciate that coming from the practical statistics for data scientists, which our book is phenomenal. I know you guys are really embracing our book because I know I have since day one. Because the good thing about the author in our book, they always make everything so granular that all you have to do is just take great notes. That's why I'm always advocating: take notes, take notes, take notes, take notes. So when you see it again, you got the notes and you can jump right on it. Okay. However, in this classification section here in week 5, I'm expecting you to nail 5 areas. Okay. Now, I just previously spoke on the naive Bayes theorem, okay? So you're going to have to make sure you understand what the naive Bayes is all about, okay? So do take good notes, okay? Because our O'Reilly Practical Statistics for Data Scientists book we know is by Peter Bruce, Andrew Bruce, and Peter Gedrick, right? Those guys made it so easy for us to make sure that we understand how they're doing it so we can basically have it all fundamentally sound. So make sure you read the chapters, guys, and make sure you read this section about the naive Bayes. Okay, make sure you understand the naive Bayes in its totality. That's crucial. Okay. Also, from the classification section in chapter 5, you're going to have to understand what discriminant analysis is all about. Same thing with logistic regression. It is imperative, guys, that you understand these items that I'm articulating to you, because there's always madness behind this madness, okay, as always, okay? So when I'm emphasizing it, as I previously spoke on, that means you're going to see it again, okay? There's always a method behind the madness, okay? That's whether you hear that common folklore. That's what that means. There's a method behind it, okay? Which behind it is the madness, okay? If you didn't know, okay? Now you know. When you hear that expression, method behind the madness, the method is these 5 items. The madness is you're going to see it again. Always be mindful of that, okay? Alrighty. Now, the 4th item out of 5 is evaluating classification models. Please, I'm saying please, guys, make sure you understand how to evaluate classification models. It is imperative, okay? And then last but not least, the 5th item is strategies for imbalanced data. I just gave you a heads up about how imbalanced data is derived, where it comes from. It just shows up imbalanced. Our job, our goal, same way, is to, as data scientists, is to cleanse that data and make it usable for the organization. So you guys will read about it. I don't want to beat that dead horse. I want you guys to beat it. I want you to read up on it and show me that you know it, okay? So make sure you know those 5 areas, guys. Once again, out of chapter 5, the classification section, it will bode well for you guys moving forward. Now, in our embedded link for this week for the modern statistics within R, okay? Once again, we're still in section 8, okay? Or chapter 8, regression models. We're still in regression models. Now, here in chapter 8, there are 4 areas that you're going to have to be SMEs on. Show me that you are the SMEs that you are, subject matter expert. That is the acronym. Show me that you guys are SMEs. 8.1, linear models. Show me that you know what linear models is all about. And the way you show me is not only reading it, but taking excellent notes. Okay. Same thing with section 8.2 out of chapter 8, of course. Ethical issues in regression modeling. Take great notes, guys. You will see this again. Section 8.3, generalized linear models. Take great notes, guys. You will see this again. And then also section 8.4, those mixed models. Okay, so it's all about differentiation, guys. If you can differentiate and understand why they're using this model, what this model is all about. Same thing with generalized linear models, right? You guys would nail it, have it down to a science. And that's what I want. I want to make sure that you guys nail everything and nothing is ambiguous to you guys. You know, you got it. You're not confused. It's not, there's no uncertainty. You got it. You understand it. So you want to stay away from uncertainty, stay away from being ambiguous. Okay, you want to actually know it, know it, know it, know it. Okay, so and that's coming out of the model statistics with the R. Go into that regression model section. Look at those 4 areas: 8.1, 8.2, 8.3, and the therefore mentioned 8.4, the mixed models. Okay, and you will be fine. Okay. And then also, last but not least, I'm always giving you supplemental material if you nail all this and you want to expound a little bit more. Do not hesitate to look at some supplemental book material to coincide with everything you just learned for this week. If and you get some downtime or you feel like you need a little bit more credence, I'm always advocating looking at some additional material and see if you can find anything that coincides with chapter 8 from your modern statistics with an R link. And the same thing with chapter 5 from our electronic book, Practical Statistics for Data Scientists, the classification section. If you can find anything that coincides with that, it's only going to bode well for you moving forward, because what you're doing is you're reinforcing what you already know by putting additional items out there that talks around it or maybe talk through it a little bit more, which may even help reinforce this material that you learned from this week, because you got some additional work that allows you to do other things in regard to understanding the concepts that I want you to make sure that you understand for this week. So any way that you can reinforce it to make it better for you as scholar practitioner leaders, data scientists, is okay with me. I'm never against doing more, Dr. Moore, Dr. Mosley, Dr. Moore, Dr. Mark, however you want to call me. I'm never as opposed to you guys doing additional work, because it only pays off as we move forward through our curriculum. Okay? Okay, guys. As I'm looking here now on this lecture 3 or 4, I'm looking to see if there's anything that I might have missed. Good old Dr. Moore, right? I covered everything in my deliverables from the overview. As I mentioned to you, I told you about the 7 module objectives by the end of this module. This module is week 4. Excuse me, week 5. Sorry, week 5. So the module is week 5. What we're going to be doing here from the content, and you got to take away those 7 things along with my deliverables that I'm also expecting that you're going to have in your hip pocket along with the module items. Okay. And I covered everything. So I'm good. I feel good about everything that I discussed. So when I come back, all we're going to do now is go over our assignments that are going to be due by the end of the week. So when I come back, guys, we'll start on lecture 4 of 4, and we will be good to go. And I don't think there's any housekeeping items that I need to discuss, because I've already reinforced to you what we have to really make sure that we do. All that I can keep saying, guys, is keep your feet on the gas pedal. Do not let off. And when you let off, that means you're getting a 0 for something that you didn't submit or something that was late. So don't be late. Continue to move forward, thus being the phenomenal SPLs, data scientists that you guys are. See you in just a bit for lecture 404. Bye-bye.